Okay, so in this example we're being asked to find the remaining terms of the recursive sequence. So notice here we have this recursive sequence. We're given z of 1, and they want us to find z of 2 and z of 3. Alright, so let's talk about how we're going to do this. So since we are provided z of 1, we're going to be able to find z of 2. And we're going to do that the following way. Notice I have z of n and z of n. I'm going to replace that with z of 1. So when I do that, I get the following. I get z of 1 plus 1 equal to z of 1 squared. So then, what we can do here is we know z of 1 plus 1 is going to be z of 2. So we can see here that z of 2 is going to be equal to z of 1 squared. And we know what z of 1 is. It's 1 plus 2y, right? It's going to be a complex number. So we're going to go ahead and plug that in. So we're going to get z of 2 is equal to, so z of 1 is 1 plus 2i squared. So in order to do this, we're simply just going to use FOIL. So we're going to go ahead and write this out. We're going to get 1 plus 2i times 1 plus 2i. Okay? So using FOIL, we do first, we get 1. We do the outside, we get plus 2i. Inside, plus 2i. And then outside, we get plus 4i squared. And then just combining our like terms, we get 1 plus 4i plus 4i squared. Now we know that I squared is equal to negative 1. So wherever I see I squared, I'm going to replace that with negative 1. And in case you forgot, we know that the square root of negative 1 is equal to I. So if we square both sides, we know that negative 1 is equal to I squared. Okay? So plugging in a negative 1 wherever we see I squared, we get the following. We get 1 plus 4i, okay, plus 4 times a negative 1. Alright, so now we're going to get 1. This is going to give us negative 4, so we're doing 1 and a negative 4. That's going to give us negative 3, so we get negative 3 plus 4i. This is what z of 2 is going to be. So we have z of 2. Let's go ahead and find z of 3. Let's go ahead and record this. Alright, so just erasing this. So writing this out, we get z of 2 is equal to negative 3 plus 4i. Let's find z of 3, so we're going to go through pretty much the same process. Let's go ahead and just erase this. Okay. So again, here we have z of n, z of n. I'm going to replace that with z of 2. So plugging that in, I get z of 2 plus 1 equal to z of 2, right, squared. So 2 plus 1 is 3, so we get z of 3 is equal to z of 2 squared. And again, we have what z of 2 is. It's negative 3 plus 4i. Okay? So we're simply going to go ahead and plug that in. So z of 3 is equal to negative 3 plus 4i squared. So same thing, we're just going to go ahead and do this operation out. So we get negative 3 plus 4i. We get negative 3 plus 4i, right? So just doing FOIL. First, we're going to get positive 9. Outside, we get negative 12i. Inside, we get negative 12i. Right, and then last, we get positive 16i squared. Let's go ahead and combine our like terms here and here. So we get 9 minus 24i plus 16i squared. Again, we have an I squared. Let's go ahead and replace that with negative 1. So we know that that's going to give us negative 16. So we get 9 minus 24i minus 16. Again, we have like terms here and here. So we're just going to go ahead and combine those. So we're going to get the following. We get 9 minus 16. That's going to give us negative 7, right? And we just have negative 24i. Okay, so now we have z of 3. So we can go ahead now and record this. So let's erase this. We now have z of 3, and it's going to be negative 7 minus 24i, right? So we just found z of 2 and z of 3 using the recursive sequence. Okay, and that is it.